Alright, so the next part of this project is we'll be sending a car down a ramp on the floor. And the object is to get the car on the floor and the car coming off of the table to collide. Piece of advice, make sure your ramps line up, otherwise your cars won't collide. Okay, mine's good enough for now for demonstration purposes. Okay, so we have a parametric equation describing the path of the car coming off the table. And we know where it will land on the ground. So now what we need to know is a parametric equation that describes the path of my car down a ramp. And we're going to use that to figure out where the car on the ramp needs to start. Maybe it needs to start up higher, maybe it needs to start down a little lower. We're going to figure that out. Okay, so the way we figure that out is we start filling in all the information we know. Okay. Acceleration in the y direction, we don't really know right now. We do know that that acceleration is caused by gravity, but we also know that it's not going to be the same as gravity. Okay, and to see that, you can take a car and release it from your ramp and drop a car from the top at the same height, and you'll see that they'll hit at different times. Hit the ground at different times. You can see your physics teacher for a better explanation of that. Okay, so we're going to calculate our acceleration in the y direction in just a second. We know what our initial velocity is in the y direction because our car is starting from rest. Since I'm releasing it, the initial y velocity is 0 meters per second. We also know our initial y position. Remember that in the first video I made my initial y position be where the edge of the table was. So since the edge of the table is where my initial y position is, or is 0, this point on the floor is 0. And I can look at my table and I can see that the ground is a height of 0 and the table is an x distance of 0 as well. So what I need to do is I need to measure on my ramp the height of where I'm releasing from to get a initial y value for the height. And the height of my ramp from here to here is 7.1 centimeters. So that's 0.071 meters. My acceleration in the x direction, we don't know that yet. We do know that it exists because otherwise, when I release the car, it would not have traveled forward. Okay? Since my car is changing distance in the y and the x, notice that it starts up higher here and is down lower here. That means that it has to be accelerating in the y direction, but it also is moving in the x direction, so it has to be accelerating in the x direction as well. Okay? So we're going to calculate my acceleration in the x direction in a little bit. The other thing we know is we also know our initial x velocity is also 0 because it's starting from rest. And we can measure our initial x position by measuring the distance that is where the edge of the table is back horizontally to where I released my car. And that distance for my setup is 0.453 meters, or 45.3 centimeters. Okay. So now I've calculated everything I've written down everything that I can measure. Now what I have to do is I have to calculate my acceleration in the y direction and my acceleration in the x direction. And to do that, all we have to do is measure the time it takes for the car to go from the top of your ramp to the bottom. So I took several measurements and took the average of it, and my average was 0.78 seconds. Okay. And so we know that my y position is described by the equation that is my initial y displacement, 0.071 meters, plus 1/2 times my acceleration in the y direction times time squared. And so I know that my time is 0.78 seconds. Now the reason I let it go all the way to the floor to calculate this time, or to measure this time, was because I want my y position to be 0. And then this way I can calculate for the one variable that I have left in my equation. And I'll leave the algebra to you, but when we calculate that, I end up with an acceleration of negative 0.233 meters per second squared. Okay, and that makes sense because my ramp has a negative slope, so the car is decreasing in y values from the top to the bottom. So that would mean that it's accelerating downward, and since my ramp is going down, that makes sense. And now what I need to do is calculate the acceleration in the x direction the same way. Okay, so x is equal to the initial x position, which was 0.453 plus 1/2 times acceleration in the x direction times my time squared. And it took 7.8 seconds for it to travel from the top to the bottom of my ramp. And again, since I let it go to the bottom, I really want to know when this x value is equal to 0. And then now I can solve for the only variable I have left in my equation. And this should be meters. Meters. There we go. And when I solve for the acceleration in the x direction, I'll leave the algebra to you, but I get negative 1.489 meters per second squared. Now I have all the values I need, and I've shown my work nice and neatly to plug in and have two sets of parametric equations. Good luck.